questions about the challenges, then, well, you can share them on the chat. I'm very happy to have some discussion with you. So my name is Michał Będkowski. I was heavily involved in creating this CTF. I created most challenges. So on my daily basis, I am a penetration tester as well as a training instructor. So my main interest is web application security but also browser security. And you can say that the security in general, I like to know stuff about everything. This is the final scoreboard of the CTF. So PMI admin was a testing account, so we don't count it into the final scoreboard. So the winner was Cortinas, if I'm pronouncing it correctly. So congratulations. And also congratulations and a big thank you for everyone who was involved in this CTF. I hope that you had much fun with all these challenges. So right now I am going into my a private deploy of the CTF, so that no challenge is currently solved in this deployment. And I will walk through all these challenges. If you have any questions, remark, anything that you would like to ask or add, then feel free to do that on chat. So maybe I will show just the screen. And let's start with the first one. I think the easiest one of them all. Basically, I wanted to make sure that everyone has read the rules. So all we have to do is to go to the rules page. Whoops, I must have stopped the server. Yeah, I did. So wait a second. Okay, it's back. So we need to go to the rules, and in the rules we have an example of a flag, but this is an actual flag. We can just submit it in the challenges. So this is the first one, I guess pretty easy. The second one is called Easter egg. So there is another flag that is hidden in the sources of this dashboard, and the question is if you can find it. And basically all you needed to do is to run developer tools in your browser. And then we need to go to the debugger, and in the debugger we can search files. So basically all we need to do is just look for PMI underscore, because this is the format of the flag. And okay, in my private instance it is a little bit easier because I have the source maps for the original code, so it is pretty obvious that I have the flag PMI look at the source look, but maybe I will have a look at the production and try to do the same here. And yeah, basically it is exactly the same, but the JavaScript is just minified and after the compilation. So the flag is PMI look at the source look. We can just prettify the sources and just copy it from here. When I deployed the initial version of this environment, then the flag was actually optimized out by the compiler, so it wasn't in the JavaScript anymore. So I needed to add something a little bit fake, like comparing into match random, so that the compiler doesn't know that it cannot really be true, but the flag is still in the sources. So the second one was just about finding the flag in the sources. So it basically checked whether you know that something like developer tools exist in the browsers. Okay, next challenge is called opening a bad link. And this is a really classic cross-site scripting, so XSS challenge. The goal is to get the document cookie of an administrator and then use the feedback function, which basically sends a URL to a simulated user that uses actually Chromium headless. And well, if our payload is okay, then we should get back the cookie on our own server. So maybe I will go back to I will go to the challenge, but then I will move into another browser because I'm using a tool that I guess that at least some of you should know. The tool is called Burp, and the Burp is a web proxy in a nutshell, so a tool that can intercept the traffic from my browser to the servers. And well, in some cases it would just be easier to show some stuff in Burp because then you could see everything what's going on in the HTTP request. So what I did right now is that I ran the page in the browser, and well, my goal is to find cross-site scripting vulnerability. So cross-site scripting is about executing your own JavaScript code in another website. And in this page, there is basically only one place in which the XSS can occur, and this place is this search. So maybe I will try to search something, and then I will go back to Burp. And in Burp and the HTTP history, I can find the HTTP request to bad link with the query ASD. Now I can send this request to another tool that is called Repeater. And Repeater is a very simple tool in which I can see the HTTP request on the left, I can press send, and then I see the response on the right. So we will see exactly what's going on here. So basically I have my query like ASD. I will look for it in the response so that you can see it highlighted like here. Okay, so we can see that the query is reflected in the response in an attribute that is called value. And in order to break anything in the HTML, in this case, I will have to escape from this value attribute. And because the value attribute is enclosed in double quotes, so I will have to use the double quote character as well. So maybe I will add a double quote at the end of the query and maybe then some letters A. After sending the request, you can clearly see that the double quote is not encoded or escaped in any way, which means that at this point I'm escaping the value attribute. Okay, so in order to execute my own JavaScript code, I can also close the whole tag, the input tag, and then I can open another tag. Like the most famous example of cross-site scripting is the code with script tag and then alert1. But we can see that the script tag is being created. However, there is a little bit of a problem. That is, the left and right parentheses were deleted. Okay, so for some reason, the application just deletes the parentheses, and we need them in order to execute functions. And it is actually quite easy to Google. I mean, you could try something like XSS without, and one of the first suggestions is XSS without brackets. So basically, you could find a really easy way to do so on Google. I will show you my favorite way to solve this problem. I mean, to execute a function without using parentheses. And the way is to use another tag. Another really famous XSS example is using the img tag, the image tag. And please notice that I am using the plus signs instead of spaces. This is because I am in a URL parameter, so I need to use the URL encoding. And plus in a URL encoding means just a space. So another famous payload for cross-site scripting is to use the image tag with the onError attribute. And when I am in the attributes, I can use the HTML entities. So for instance, there is a very famous entity like endLT, and the browser automatically decodes the entity &LT to just the less than character. And there is also an entity for the left parenthesis, and that entity is just lpar. And for the right one is the rpar. I need to do one more thing here. I need to escape the ampersand because the ampersand has a special meaning in the URL. So its encoded form is just %26. This is something that Burp can do automatically. Okay, and as you can see in the response, I have the image tag with the alert, and instead of the parentheses, I have the HTML entities lpar and rpar. Maybe I will check if the alert executes in the browser. Okay, and as you can see, the alert is executed. So I proved that I can execute JavaScript functions. So what I need to do right now is that I need to exfiltrate the document cookie of the user. And for that, I can use the webhook.site. The basic premise of webhook.site is that it generates a unique URL for you. And whenever somebody visits this URL, like I can visit it, then we get some information like that this URL was visited from this IP address, and we also get headers. So what I can do right now is that instead of the alert, I can use a fetch function. This is a JavaScript function that just fetches a given URL. And I will pass the URL as a parameter. And at the very end, I will add a question mark. And this is to add a parameter to the webhook.site. And maybe I will add a new parameter that is called cookie. And afterwards, I will concatenate the document cookie. Right, so right now I'm creating a URL to webhook.site that also adds the document cookie. So here's one little problem, is that the plus sign was converted into a space. This is because of the URL encoding. So I need to encode the plus sign into %2b. Okay, so now I have the fetch, and let's check if it works. So I will copy the URL to my own browser. And after a short while, you can see that there is another request, and it includes the cookie parameter. So it works for my own browser. So all I need to do right now is to use the feedback function. And then the simulated user will check this URL, and I will just get the cookies of that user. So I'm using send feedback, and after like a few seconds, I should get that information. Thank you for feedback. And then you can see that I got a request from another IP address, and it includes the cookie parameter with session is equal to something. So in order to finish the challenge, all I need to do is to change my own browser's configuration in such a way that the cookie is being set in my browser. So I'm opening the developer tools, and I'm using the application tab. And in the application tab, I can set the session cookie to the value I just exfiltrated. Now I need to just refresh the page so that the browser will send the new cookie, and I got another flag because now I am logged in as an administrator. So let's check that. And yes, it works. So the basic idea is that I exploited cross-site scripting to get the cookie of an administrator user. And this is a real-world example of what you can do with cross-site scripting. So cross-site scripting is not about alert one, but cross-site scripting is, among others, about stealing the session of the logged-in user. Okay, next two challenges are really similar. I mean, they start with exactly the same vulnerability. So here we have another, we can say, common web application vulnerability, that is SQL injection. And we have two goals here. The first goal is to just crack password of one of the users using publicly available sources. And in the second case, we need to crack the password by ourselves. So let's do both at the same time. I'm going to my, it's here, to my Chromium. And here the SQL injection is also in the search form. And the most basic way to find SQL injection is just to add the single quote character, like here. And when I will try to use the search, then in the response I'm getting a SQL error. And this is a really simple way to find for SQL injections, but it seems to be surprisingly effective in the real world. I mean, if the application has this vulnerability, then just using a single quote might uncover it. So what is the typical way of exploiting SQL injection? Well, maybe I will run a page that is called dbfiddle to show you some examples. From the error, we already know that the database that is used in this application is SQLite. So I think that we can use SQLite in dbfiddle. Okay, and dbfiddle is a really useful application because we can use different kinds of databases and we can just write a query online and see the result. So it is really neat for testing how a particular database management system is behaving. So the basic premise of exploitation of SQL injection is that the application has some kind of a original query, like select something from somewhere where something happens, like maybe username is equal to ABC. And the injection means that we can inject our own query here. Like so here we can inject our own query. And the typical way to exploit that is just to use the union select here. So the idea is that we are basically performing two selects, and those selects, the results from those selects are merged into one. So the problem with that is, maybe I will remove the from and where. The problem is that the first and the second select must have the same number of columns. And for instance, well, in this example, I can see how many columns the original select has, but in this application, I don't know that. I cannot see the original query. But the very easy way to check that is just to guess. I mean, I can guess that maybe there is one column. Okay, I'm getting an error, so that's not the case. Maybe there are two columns, also error. Sorry. And let's check three columns, and I don't have any error with three columns. So now I know that there are three columns. And this is exactly what I'm going to do in this example. So maybe I will do that in burp so that you can see better what's going on. Maybe I will change the size of font so that it's a little bit bigger, maybe 32. Let's see. Okay, I think that should be legible. So the first thing that I need to do is that I need to use the single quote so that I can escape the SQL string. The second thing that is usually done is that I use the SQL comment so that everything that follows in the original SQL query is now commented out, so I don't need to care about that. Okay, so let me try to use the union select, and maybe I will try to use one column, and I will remove the header if not match so that I can always see the response. So in this case we are getting the SQLite error, so maybe two columns. Also SQLite error, so maybe three columns. And now I'm not getting any error. So I know that the original select has three columns. Now the second thing to do would be to get data from some table. but I don't know names of the tables in this particular database. And basically in every single database management system, you can get some information about the database itself using some special tables. For instance, in MySQL or Postgres or SQL Server by Microsoft, you can get the information about tables from information schema tables. In SQLite, we don't have information schema, but we have something that is called SQLite schema, if I remember correctly. And then we can use a column that is called SQL. So we are just getting the column SQL from SQLite schema. Okay, and SQLite schema just contains an information about the SQL query that was invoked in order to create tables. So we can see create table posts, and we can also see the create table users. So we know the exact name of the table in this case. And I used some random characters in the table name and also in the columns names so that it wasn't like brute forceable, so that you cannot just guess that there is a table users and the column name username and the column name password. You just needed to get that information from the database because, well, it would just take too long to guess the names of those columns. Okay, so now I know that the table name is users and something, so I can change my select on the left, and now I can select data from the table users, and I will get a concatenation of the username. Then I will add maybe a slash character and then a password. Okay, and now I'm getting 2 users with 2 passwords. We can see that the passwords are hashed, and well, by looking at the length of these hashes, we can guess that the hash in question in here is the SHA1. Okay, and the really easy way to crack some hashes is just to use Google. So in the first case, we can find out that this hash is for passwords, well, basically the first 3 rows on the keyboard. So now when we know the password, we can go back into the browser, use the login, and now admin, and paste the password, and now we have a classic SQL injection. Maybe I will just submit the flag, and okay, it works. Okay, so this is the first password. The second password cannot be found in the databases in the internet. This is a password that we know that is in the format of the flag. So PMI underscore and then something. And we can use a tool that is called hashcat to, well, crack the password. And I will show you how hashcat can be used. Okay, I will just make sure that the pod file is removed. Okay, so hashcat is a tool that can be used for cracking hashes, but officially it is a password recovery tool. So, you know, if you forget your password, but you remember the hash, then you can use hashcat to recover the password. In the real world, I actually used hashcat to recover my password once. I created a Veracrypt volume once, and I forgot the password for it, but I remembered the pattern, and yeah, I indeed used hashcat to try to recover the password because I just forgot it. But well, I guess that in most cases hashcat is being used for cracking passwords. So there is a few parameters that we need to pass to hashcat. Basically, hashcat has a few modes of operation, but the mode that we will use is just brute force. So we will try to brute force the password with the knowledge that the first 4 characters are PMI and underscore. Okay, so this is what we'll do. So this is the attack mode with number 3. And also we need to tell Hashcat what is the hash type. And as you can see, it supports many types of hashes. But we already established that we are using SHA-1, so we need to use the hash mode that has a number 100. So I'm going to call the hashcat with A3, so the brute force attack, and the mode 100, so SHA-1. The next parameter to hashcat needs to be the hash itself, so this one. And the last, or maybe not the last, the next parameter will be the pattern. And we know that the password is going to start with PMI underscore. And then I will use something like $1 a few times. So this is called a mask in hashcat. So I'm referencing the first mask. And now I can define the mask with the parameter -1. And I'm defining that this mask is basically lowercase, characters, digits, and uppercase. So hashcat will try to guess the password using this knowledge that it needs to start with PMI underscore and then some instances of this first mask. But I don't know the length of this password, so I will use also another parameter that is called -I, and this is I from increment. So basically, hashcat will try to use a password that have 1 character, 2 characters, 3 characters, and so on, until it finds a match. Okay, and in this case, I'm running this in a virtual machine with a quite good GPU, but on your laptops or computers, the cracking probably shouldn't take longer than like 40 minutes, maybe 1 hour. Basically, the password is not really that long. As we can see on this computer, on this virtual machine, the whole process will be finished in maximum 3 minutes, because we are already at the length of 10. So everything that was before was already checked. So basically, hashcat right now tries every possible combination of the characters and check if the hash matches. And hashcat is a really nice tool because it is just amazingly fast. It can use power of GPU to calculate the hashes really efficiently. So maybe we will wait a little while so that we can see the result. What is the password? Basically, the virtual machine I created it on Linode, and it is like $1 for hour. So basically, it is quite expensive if you wanted to have it for the whole month. But basically, I need it for like 30 minutes. So $1 is not that bad. Okay, we're halfway through, but still not quite there. So let's wait a short while. Okay, let's see. Maybe in the meantime, I will just check, because I don't remember how many people are able to crack the password. Okay, so we can see solved by 4 teams, so 4 people cracked the password. So good job. And okay, in the meantime, hashcat stopped, and here above we can see that this is the password. So this is basically the flag. So all I need to do right now is just to use the correct password as the flag, and here we go. We get the flag. So we abused SQL injection to get data from database, and then a hash of 1 password could be found in the internet just by googling it, while the second password needed to be cracked, for instance using hashcat. Okay, so the next challenge is the Android application. And there are two challenges. The second one is with the difficulty medium, but because they are in the same application, I will just show those two challenges at once because they are kinda intersecting with each other. So we have an Android application and there is a flag in a plain text. And as far as I remember, many of you could find this flag, so pretty good. And yeah, let's just download the APK and see what we can do. So in order to solve the challenges, both the challenges, we don't really have to have a Android device because everything can be done just on our computer, even without emulator. I mean, you could solve it with emulator if you wanted to, but it wasn't really needed. I can show you that the second challenge could be solved using just a static code analysis. Okay, so what we can do right now is that we can use maybe I will use this browser. We can use an application that is called JADX. Sorry if I'm not pronouncing it correctly, JADX. JADX is a really nice decompiler. We can just feed the APK file to JADX and we will get a decompiled Java code. So this is what I'm going to do. I will just run JADX on the second screen and I will move it in a short while. Okay, just wait a short while. Okay, so I told it to open the APK that I just downloaded, and we can have a look at the source code. We can see the classes. Here we have CAM example, a really simple application, and here's the main activity. We can see main activity KT, so we can guess that this application was written in Kotlin, not in Java. But yeah, the first flag is basically just here. So the first flag was just checking if you know that Java code or Android code can be really easy decompiled. And yeah, this is how it looks like. Basically just as a Java code, and now we can see that the flag is here in the plain text. So I will just submit it. Perfect. But then we have a second Android challenge. And in this one, we need to do some kind of reversing. So the other flag is not in the plain side. So let's have a look at the code and try to figure it out what exactly is going on. Maybe let's start with the main activity and see what is being run here. So we can see that in the constructor, oh sorry, this is not a constructor, here we have the onCreate, but basically we can see here a function that is being called, that creates another class, so we can check what exactly is going on. Okay, nothing really interesting in this one. Maybe let's have a look at the other one. And here we have something really interesting, like a bigger snippet of code. And let's try to get some sense from it. We can see that we have the HTTPS URL connection. So what happens here is that the application is trying to open some URL. We don't know what kind of URL. We will have a look at this in a moment. So it tries to open some kind of URL and, well, basically just reads the response. And the question is, what is the URL? Well, we can see that we use the base64 decode on some string. So some string is being decoded from base64. So this one is decoded from base64. And the second step, where is the, here? Okay, so the first step is that this string is decoded from base64. And then, as you can see, the decode is also used in some other function. So basically this function returns a URL that is an argument to the URL constructor. Okay, so let's have a look what this function exactly does. And it might not be really legible at the first sight, but this is basically just because of these, I guess, excessive casting. So let's have a look what's going on. So the argument to this function was the decoded base64 string. And now we can see that we are iterating over the length of this argument. And we have a few XOR operations. So we are XORing this string, so the previous flag, with characters from this input string, and also with the iterator variable. As you can see, this is just an incremented variable. And finally with 1. We can also see that we are getting the character from this string that is modulo 35, but the guess can be that the 35 is just the length of the string, so that we don't want to get out of bands, so we use the modulo 35 to, you know, when we are at the last letter, then we are going back at the beginning. So maybe I will try to re-implement this function in Python. I mean, you could just copy this function to a Java compiler and, well, execute it without any changes. But I don't have this type of environment in here, so maybe I will use just Python. So maybe I will take the flag, because as we know, it will be used. Okay, I will also import base64 module, because this string will be decoded from base64. This was the first step in the main activity. Okay, so maybe I will call it magic, and I will just use the base64 decode on this magic string. Okay, there's nothing really interesting in this string. We don't know what exactly is inside. Okay, so now I need to implement this function, so all this magic XORing that happens in here. And for that, I will use a zip function in Python. Basically, when I have a zip function in Python, then I can get two sequences, and I'm getting a loop that goes over the first sequence and the second sequence at the same time. So maybe I will show you the results from zipping. And as you can see, I'm getting the first character from the first sequence and the first character from the second sequence, then the second character from the first sequence and the second character from the second sequence, and so on and so forth. Okay, so right now I need to zip over the magic and flag. Okay, so let's do this. But there is also another thing, that the flag, I mean, we can reach the end of the flag. So here we have the modulo 35. By the way, this is actually the length of this flag. This is why the 35 shows up in the source code. So I will do something a little bit simpler here. So in my zip, I will use a flag maybe times 5. So I won't do any modular arithmetic. I will just use the flag several times so that I am not getting out of bounds on this one. Okay, and now as you can see, I have every character from the flag along with every character from this magic string that was decoded from base64. Okay, but there is one thing I need to change, and this is something Python specific, that the flag needs to be a byte string, not a string. Okay, and now what we know is going on here is that those characters are just XORed, right? So this is the character from this flag that is being XORed, and this is the character from this decoded base64 that is being XORed. Furthermore, I need to XOR it with the variable and also XOR it with 1. So maybe I can add the XOR 1 in here. I can create bytes from it. So far, nothing really something that I could recognize. But the last thing that I'm missing is just to XOR it with the iterator. So maybe I will do that in another loop. So I will use the enumerate function in Python. So I will enumerate the bytes. Okay. And then what I will get in the response, as you can see, is that all those bytes that were already XORed with the index of those bytes. Okay. So the first element in this tuple is index. The second one is just byte. So what I need to do is that I need to XOR index with byte. And then I will change the numerical codes of the bytes to just bytes. And yeah, I'm getting something that makes sense finally. So this is basically an obfuscated link to a paste bin. So let's have a look at the paste bin. Okay, maybe we expected something better here. So we have some random string here. Okay, maybe I will call it magic2. And it will also have to be the byte string. So let's go back to the code and let's see what happens with the response from this paste bin. Okay, so we can see that here we are reading data from the URL, and we have a simple XORing operation one more time, basically. So this time everything is XORed with this. So we have some other magic sequence of numbers. And okay, let me go back here. Maybe I will call it magic3. So all I need to do right now is just to use another zipping of magic2 and magic3 and another XORing, and then I need to change it to bytes one more time. And after doing so, we are getting the flag. So a little fun with an Android application. So Christopher says that he solved it by intercepting the trust manager and removing the throw error in Smalley. So yes, this was the solution that I have shown you is basically a static solution. I mean, you don't need to execute the original code. However, if you wanted to execute the code, then you would always get a TLS error or SSL error, and it is possible to just change the code in the APK. So basically, in JDEX you can also see Smalley, and Smalley is some kind of an assembler for Android. And there are also tools that can create an APK from Smalley. So the idea is that you can change an implementation of method. In this case, you would need to delete all the code from check server trusted. And the second thing that you would have to do is you just need to perhaps change this condition or just remove this condition, because everything would then happen automatically. So yeah, I have shown the solution with reversing the logic, because I wanted to show that you don't need to have an Android device to be able to solve this challenge. And perhaps with an Android device the challenge is a little bit easier, but you also need to be aware of the fact that you can just recompile the application, or maybe there are a few ways. You can change the APK and install a new version of the APK. You could use a really neat tool that is called Frida, and with Frida you can change the way a function works in a dynamic way. It is a really nice tool. And there is also another tool for Android, but I forgot its name. Let me think for a while. Maybe I will try to Google it. Change method dynamically. Maybe something like this. Okay, this is not what I wanted. Sorry, maybe I will remember that in some time. There is also another really popular tool that you can use to change how a function or method behaves. But basically when I'm doing this kind of stuff, I'm using Frida. Frida worked for Android, for the iOS, and also for the desktop operating systems. So it is really, really nice tool. Okay, so to finish things up, I will copy the flag and paste it in Android reversing, and yeah, I got the response. So that's good. We almost have all the easy ones. Now we have two more flags in one application, and this application is called manual block. So the first challenge is about a hidden administrator panel. So the first thing that we need to do is to find the panel, and the second thing we need to do is to just brute force the login and password. And I provided two lists that you can use in order to do the brute forcing. And the second challenge is that there is a hidden node in the block. And maybe I will start with the second one because basically it is easier. So when you go to any node, maybe I will go back to burp. Sorry for the browser. Okay. When you read any node, then you can see the ID parameter. Okay, and when you go to the last node, the ID parameter is 3. So you might think, okay, what's going to happen when I say 4? And yeah, this doesn't exist. So maybe 10. It also doesn't exist. So maybe 20. And it seems that it does exist. So there are more nodes in this block. And as you can guess, one of the nodes has the flag. So we just need to automate the process of going through the nodes and finding the flag. And this can be automated pretty easily. We can just use curl or Carl. I don't really know how to pronounce the name of this tool. CURL or curl. When I'm saying the name in Polish, I always say curl, and maybe this is how it should be done. Anyway, I can create a really short loop in bash. So I will create a for I in sequence from maybe 1 to 100. Maybe at the first example I will use just echo. And as you can see, I have a simple loop in bash. And what I will have to do is that I will need to, maybe I will keep the echo, but I will need to run curl, let's say. Okay, so I will run all these commands. And the next step is just need to grep for PMI underscore. I will also just disregard the errors. So the only thing I am going to see is the flag. So now I can remove the echo and just wait a little while until curl will find the right node. Okay, so we have something, and yeah, here's the flag. And this is the second flag because this is the secret node. So I don't really know the ID of this node because, well, because of the way I have written the script, but it doesn't really matter. I have the flag, so that's all that's important. Great. Now the secret administrator panel. Well, it can be. So perhaps the first check is to check the /admin, but nope, it doesn't work. So maybe, I don't know, panel or something else. I guess that at least some of you tried some brute forcing in here. But the place that you needed to look at is called robots.txt. Basically, robots.txt is a file which is an information for search engines what content should not be indexed on our page. And it really happens in the real world that sometimes you can find some interesting stuff in robots.txt, because when somebody says, hey, don't index this page in my application, well, then maybe this page contains something interesting. And this is exactly what's going on here. So now I have the URL for the administrator panel. And the next step is just to brute force the username and the password. So I can use the lists that I have here. Maybe I will open them in new tabs. Okay, so the first list is for usernames, and I will start with brute forcing just the usernames. Okay, I have the information invalid credentials, so I don't know if the username is correct or if the password is incorrect, but you would see that you could tell what exactly is incorrect. So now I'm going to find the request to logging in Burp, and I will send it to another tool that is called Intruder. And Intruder is a really nice tool because I can use it for automatic attacks. So I can say that I want to attack this exact place in the HTTP request. Okay, so the username test. And now in the next step, I can just paste the payloads. And when I press start attack, what happens right now is that Burp sends all those requests automatically. Maybe I will show you that. Okay, with all those usernames. You could script it in any language if you wish, but basically this is why many pentesters use Burp, because stuff like that are really common and it is really easy to use. Okay, so maybe I will check if any response differs. And as you can see, one response is a little bit different from all the other ones. And yeah, basically we can see that all location headers in all other responses have just one ampersand at the very end, while in this case, in the single username, we have two. And of course, we don't know what exactly it means, but the fact that there is a single response that is different from all the other ones can be an indication that this is actually a valid username. Okay, and something like this sometimes happens in real applications. The example is that the applications show a general information like invalid username or password, but the URL contains, for instance, error is equal to 1 or error is equal to 2. So even if the information itself is the same, we can guess that, okay, something is different. So we can guess that the NAadmin is the correct username in this case. Okay, so I will run the attack again, but now I will use the password that the username, sorry, that I already know, and I will attack the password. So let me get the password list. Okay, I will clear the previous list and paste the new list. And well, one more time, I will check for any response that is different from all the other ones. And we can see that this happens when the password is Disney. And yeah, the flag is PMI, a little bit of brute forcing. So if you don't use Burp, then basically you probably needed to write your own script to do the brute forcing, but well, it is not that difficult to do so. Burp was not really required to perform this challenge, but it just makes it a little bit easier. Okay, so I found the secret admin panel and I made my way in. Perfect. The next challenge is about the AWS. And there is also another challenge that is, well, connected to this challenge. This is the Lambda Delta Sigma. So I will show these two challenges together, similar to Android. Okay, so we have an application where, yeah, I remember when I was writing this description, I had a problem that I have an application when I can submit an application. It doesn't sound good, but it is true in this case. And okay, here's the description in the production was actually different. And because in the original challenge there was another CV with the flag, but then I decided that, well, many people will submit the job application, so there will be many CVs, and it doesn't really make sense to hide it there. So in the final version of the challenge, the flag was in flag.txt. Okay, so let's have a look. Maybe I will use the Chromium again. Yeah, Hydra is also a really known tool for brute forcing. You could also probably use a tool that is really popular recently that is called FFUF, FUF, I guess. And yeah, the FFUF stands for the fast, faster, you fool. So this is a fuzzer written in Go, who is supposed to be fast, and it is really fast. So I guess that probably it would be faster than Hydra. Okay, so I can apply for work, and I will upload a PDF in here. So I'm just finding some PDF on my other screen. You will see it in a short while. Okay, I have some PDF. Okay, Smile PDF. Then I press submit. And okay, the data was saved, and now I can access the CV that I sent. But let's have a look at the URL of the CV, and you can see that it is in the S3 bucket that is called CTF1. And the first thing that we can check is what happens when we try to go to the CV directory just directly in the browser. But in this case, we are getting the access denied error. However, it is possible that this bucket is configured in such a way that the anonymous user cannot access the content. However, if we are just logged in as anyone, then we will be able to do so. So now we will have to use the command line interface of AWS. I think I should have it somewhere in here, and if I don't, I will just find it. I don't want to install it, so I run the CLI as a Docker, because I don't want to install too much stuff on my host. And yes, it is possible to run the CLI directly from Docker, so this is pretty neat. Okay. And I need to do one more thing. Maybe I will just run it. I have the AWS credentials file in here with some account on AWS. So this application, this command line interface will use these credentials. And I need to use a volume with the credentials. I wanted to check the exact parameters, so I need to pass the current directory, and yeah, okay. I took over 1 hour with Hydra for me. He did it in 2 minutes. The question is, if you tried to brute force login and password at the same time, because if you did, then well, I just sent like 2000 requests, and if you tried every possible combination of username and password, then well, you had like 1 million requests or sent, so it could take much longer. So anyway, I can now use I will just check if it works, the AWS command line interface, and it works. So now I can use the S3 parameter in the tool. Okay, and well, I'm getting some error, but basically, oh sorry, I also made another mistake. I think that the V parameter needs to be a little bit earlier. Okay, now I'm getting what I expected, so I have too few arguments for S3. So what I can do right now is that I can try to list the contents of the S3 bucket, and I just need to remember its name. It was just CTF -1. Okay, so I can use like S3 CTF -1. And yeah, I can get the directory listing in this case, which means that this bucket is misconfigured in such a way that I can get the listing, and probably I can also get the file. But here's a little problem. If I use Docker this way, I think I create another volume, maybe to my current directory, which will be in maybe, I don't know, test in the Docker. And now I can use the cp command in the S3, and I will copy it to my local directory that is called test. Oh, sorry, but I didn't specify what I want to copy. So I want to copy this file. Okay, and now I have the file. Maybe I will add an echo at the very end, so there's a new line. Okay, so now I have the flag for just getting the file for the improperly secured S3 bucket. This is actually quite a common misconfiguration. Okay, so this is the first challenge. Yeah, now I can see that Mariana sent 800,000 requests, so it's not really surprising that that it took more than 1 hour. What's also funny is that sometimes when I'm providing some trainings and there is some kind of brute forcing on the training, then some people are getting blocked by their ISP when they try to, solve the challenge on the training. So I think that's good that it didn't happen to you. Okay, so this was the first challenge with the job application, and the second one is called Lambda Delta Sigma, and I think that the description was also changed in the end. So when we have a closer look at the bucket, there is also a reference to another service, and then we can get a source code from some Lambda, and then there is a flag. So now I'm going to do exactly the same what Christopher did. So basically I will use, I will use not cp but sync. So I will copy all the files from the bucket. Okay, so one colleague was blocked by SOC. Yeah, that's not really surprising. Okay, let's wait a short while until everything is downloaded. Okay, I think that it went much faster when I tried this before, but I did it in a slightly different setup, so this might be why. I guess that the connection, or the volume of Docker is what makes it slow. Okay, so now I have all files from the bucket, and now I just need to do some exploration. I mean, I don't know what exactly I am looking for, I just know that there is a reference for something else. And, well, I will just go to the exact place that I have to, but basically you probably just did some exploration. Maybe you use some kind of grep if you had any idea what exactly you are looking for. So yeah, here we have link to API. And this is basically the beginning of the second challenge. So let's see what happens here. And yeah, this challenge was actually broken for some time, and I really apologize for that. It turned out that somebody must have changed something in the policy that basically broke it. And also we were getting some budgeting errors in this case. So yeah, we don't really know what exactly happened, why it went away. But yeah, at some point this challenge was broken. When I was made aware of that, I wrote an information in the announcements, but I must admit that it is pretty unfortunate, because in this case you probably didn't even know that this challenge is broken, because you could do the first steps, but then you couldn't do the next step I'm going to show in a short time. Anyway, going back to this challenge, I have some access key and secret access key, so I think that the most wise thing to do would be to just use those data, because, well, they are here for a reason. So I'm going to change the access key ID, and I'm going to change the secret access key. Okay, let me copy all of this. And well, let's just explore who we are, what we can do. So I am going to use the IAM and then maybe get user. Okay, so now I know what is my username, CTF2, and some kind of UID. And well, the goal in this challenge was to get a source code of another Lambda. So maybe let me try to do this in the first place. So what I can do is Lambda list functions, if I remember correctly. We must also specify our region, so maybe EU central 1. I don't know so far, I can just, guess. But in this case, I'm getting an error that I am not authorized to do this action. And this is actually a part of this challenge so far, that I cannot access the Lambda at this point. Okay, so maybe I should check my permissions. And there is a command in the IAM that is called, I think, list attach user policies. Okay, so I will use the list attach user policies. Sorry, I need the username of my user, so maybe I will get it again. Okay, so this is my username, and then minus username, and here we go. Okay, so there is one policy that is attached to my user. Here I have the policy ARN. So maybe the next step would be just to find out something more about this policy. And I will just check what versions this policy have. So this is list policy versions, and then minus minus policy ARN, and the ARN of the policy. Okay, and as we can see, the default version, the current version is the v4, but we also have some other policies like v3, v2, and v1. So at this point, I will try to get some information about the specific versions, like get policy version, and then minus minus version ID, maybe the default one, like v4. Okay, I can see the policy. Maybe let's just check another one. Okay, some other permissions are here, like list buckets, get object on S3. Maybe let's have a look at v2. And with v2, we see something that is really interesting in terms of this challenge. I mean, we have the permission to list functions in Lambda, and we also have the permission to get function in Lambda. And we have specific information about this function, that it is in the region EU Central 1, and we know the name of this function, which is CTF2 flag. So what we need to do right now is that we need to change the default policy version to v2. So it was, I think, set policy version. Nope. Sorry, I think it was set default policy version. Okay, no error, and when the challenge was broken, this was the place when you got the error. You couldn't change the default policy version because the permission to change the default policy version was taken away from you. That was the bug that happened. Somebody probably during the exploration of this challenge just made this kind of change, and basically it made the challenge unsolvable. But right now I changed the policy version. So right now what I can do is to go back to the Lambda list functions just to check if it works. Okay, region. So EU Central 1. And yeah, now it works. I'm not getting any permission errors. So, well, I already knew that the function name is CTF2 flag. And then I forgot the name of the command for getting the function, but let's check that. No, it was just get function. Okay, perhaps. So let's try it. Get function. Okay, I need to specify the function name, of course. So it was CTF2 flag. Something is sorry, no, I misremembered what I need to do. At the very end of the get function, I get the location where for the S3 bucket that I can get the source code of this Lambda. So now I can go, for instance, for burp, and when I try to it is compressed. Okay, so burp will not decompress that. Okay, so maybe I will open it in the browser. Okay, then I'm pressing the zip, it gets decompressed. And maybe I will show you from the terminal because the font is big here. What decompressed from that zip was called lambda function py, and here we have the flag. Okay, so yeah, about changing the policy for the group. Yeah, it shouldn't have been possible. So basically, you uncovered a mistake in the setup of this challenge, because that shouldn't be possible to do so. So yeah, in the end, I'm getting the flag. So this challenge was about finding the URL for the service that returned the access key, and then we have the issue with this permissions, and this is also really important in your real world applications, that it is possible that you will change permissions for some actions, but then you missed that step that somebody will be able to change the permission back, and this is exactly what this challenge was trying to show for you, that you need to be aware of that, because, well, I wouldn't call it a common misconfiguration, but it happens. Okay, and another challenge with AWS is a whole host of issues. And here we have an information that we moved a reverse proxy from on-premise to AWS, and while there is a flag on another service that works on localhost. And this challenge could be, well, pretty discouraging at the first sight, because all we get is just a default Nginx page and, well, nothing else. But there are two hints in the description of this challenge. The first hint is that it is a reverse proxy, so we know that this Nginx works as a reverse proxy. And the second hint was the title. And perhaps if you copied the title and pasted it somewhere so that it is not capitalized, the hint would be more visible. That the host is capitalized also. I mean, the first letter is uppercase. So it is an indication that the solution has something to do with the host header. Okay, so let me refresh the page. And let's try to do something with the information that we just got. So we know that this server works as a reverse proxy, and we know that we need to do something with the host header. And basically, a reverse proxy is a server that can make a decision of sending a request to another server, for instance, in the local area network or in the cloud, based on, for instance, the path, or maybe on the host header. And there is one really interesting host in the EC2 of the Amazon, and this is a host with some metadata, and it has a fixed IP that is 169.254.169.254. And as you can see, when I change the host header, the reverse proxy just proxied the request to this host. So basically, what we have in this particular case can be thought as the SSRF vulnerability, that is server-side request forgery. So we can make requests to another host in the same network that the server lies in. And from now we can get some interesting information. Let's have a look at the folder that is called latest. And then maybe user data. We just needed to do some exploration here, as usual. Okay, here is something interesting. And at the very end, we have an information that there is a service at localhost at the port 5000, and we have the information that we need to pass login and password. And here's the login, here's the password. So let's try doing so. Okay, so I need to, maybe I will copy the password because the login is easy to remember. So what I need to do is to send a request with login is equal to tester, password is equal to this UUID, and then the host needs to be localhost and the port 5000, just like here. Okay, and I'm getting bad gateway. Maybe I will try it like here. Okay. So when I use the IP address, not the host name, I'm getting the flag. So basically, I'm accessing another service in the local host in this case. So pretty neat. And well, this is something that can happen in reverse proxies, but in fact it doesn't happen that often, because usually the configuration of this type of server is that we have some fixed list of hosts that we accept. But if we don't have a fixed list and we just do a reverse proxy, then something like this can happen. Okay, so here's the whole host of issues. And there is another connected challenge, another whole host of issues. And the goal in this case is to find the SSH key to a certain service. And well, then we need to get the flag from the home directory of the user. So we will still be in the same application, but now we will do something a little bit different, but basically we will continue our exploration in the beginning. Sorry, because my computer got a little bit slow right now. Okay. So let's go back into our metadata host, and let's try to have a look what else we got here. So we have a metadata. So let's have a look at the metadata, and a directory which might be interesting is IAM, because well, this is something with the identity management. So let's have a look. And here we have security credentials. This is a really interesting name of a folder. And here we have CTF tree. So well, at this point we already know that we look at the right place. Okay, and in this place we have another access key and secret access key to another service. So let's have a look what we can do here. So I will just copy this data and well, update it in the credentials file. I will also have to copy the token that is here, but to be quite honest, I don't remember the field name in the configuration. So I will have a look at the documentation. So AWS credentials file. And the name is, let's have a look, maybe I will just search for token. Yes, this is AWS session token. Okay, so AWS session token, and I just need to paste this value. Okay. So now I can use the CLI again. And let's see what we have here. We know that the goal is to find the SSH key, so we can guess that it will have something to do with S3, with buckets. So I think there was a command list buckets, no list buckets, ls. Okay, and we can see that there is a bucket that is called CTF3B. So basically for the third challenge, because earlier we have the CTF1. Okay, so let's have a look what we have in this particular bucket, CTF3B. And yeah, here's the SSH. So that looks pretty neat. Maybe I will copy this for my test directory. Okay, and here we have the private key for SSH. So it looks pretty promising. Now the question is, which service, to what is this private key? And I can do something really simple at the very beginning. I will just decode it from base 64. And what I'm getting from this is that at the very end, I get the username. So I know that the username for this, who uses this private key, is called CTF3. This is something that you had to take from this private key, because otherwise you just needed to brute force this stuff. And where can we use it? Well, maybe the first guess can be exactly the same server. So let's check whether the server has the SSH. So maybe I will just try to do SSH to the server without the HTTP part, of course. And yeah, it does. And as we can see, the only way we can log in is using the key. So perhaps this is the server where we need to use the key. So maybe I will run a Docker container with Debian, because I don't want to change anything on my host. Okay. And okay, I will use the apt update. And then I will install the OpenSSH client, because I think it's not installed in this container. Okay, and now I can use this private key in the location it should be. So I should have the .ssh folder in my home directory. And then the file needs to be named ID_RSA. Oh, I don't have bin, but I don't need it. Okay, and now I can try to do SSH onto the server. I will copy the URL again. Okay, and permissions are to open. Okay, I need to change the permissions for ID_RSA, that's right. So the permissions should be, I guess, 400, so that only I can read it, but nothing changed. Oh, sorry, I used chown, not chmode. So let's try it again. Okay, sorry. So now chmode 400, that should be right. Okay, so now only I can read the file. So let's now try to connect. And it succeeded. Now there is a file that I guess should be named flag.txt, but it's called flaga.txt, so basically flaga is flag in Polish. I guess this is the reason. So yeah, I was able to get the SSH private key from the bucket, and then I use it to connect to the server, and after connecting I can get the flag. So really nice challenge. And to get the point to the server, I needed to have a look at the metadata a little bit more. So yeah, the exploration was quite important in this one. Okay, so we have many challenges after us, but a few are still coming. But I think that at this point, maybe let's have a short break. At least I need a short break. So maybe a 10-minute break. And after the break, I will move on to the challenges that are left. So maybe I will show a short information that we will continue at maybe, maybe you are in different time zones, so I guess it is currently like 2 p.m. GMT. I should subtract out 2. Yeah, 2 p.m. Right? Or not? Or 4 p.m. GMT. Sorry. I think it's 4 p.m. GMT. Or I will just check that because I'm a little bit lost. GMT time. 14. Okay, sorry. So 2 p.m. Basically in 10 minutes. Sorry, I got a little confused about the time. So see you in 10 minutes and then I will finish the rest of the challenges. If you have any questions in the meantime, then do not hesitate to ask. So see you in 10 minutes. Okay, so we are back after a short break. Let me show the screen, and let's go back to these challenges. I'm just making sure that all the easy ones are solved. I mean, those with difficulty easy. And yeah, we got it. So now let's go to the remaining challenges from difficulty medium. We have 2 challenges in here and 3 challenges in the difficulty hard. So the next challenge is, well, actually called challenge response. And in this challenge, we don't use an HTTP as our protocol, but we have some special protocol and we need to use netcat to connect the service. Maybe let's have a look how it looks like. So I will copy the URL, and then I can use netcat to copy, to connect to the service. And as you can see, I'm getting some kind of challenge, and my job is to input some response. And at this point, I'm getting just an information that this response is not valid. And well, solving this challenge is basically impossible if we don't have any information about the binary. So this is why this binary is available for download. So let me download it. And then we will have a look at this binary. So maybe I will go to a directory that I will call maybe challenge response, because this is how this challenge is called. And then I will copy this this binary here. So I have chal without flag gz. Okay, so let's gunzip it. Okay, and now we have a binary file. So in order to find out what we can do with this, we need some kind of a disassembler or the compiler. I mean, Java can be decompiled pretty nicely, but the same is not really true for like C or C++. There's something that we can do, but basically we don't have results that are as good as in Java. And the tool that we can use probably, and which is really popular recently, is called Ghidra. I think this is how it's pronounced. It is developed by the famous NSA in the USA, and we can use this tool to disassemble the binary and just get some information about it. But if we try to do so, then we wouldn't get anything interesting in Ghidra. I mean, it wouldn't be able to disassemble it. And the reason for that is that this application makes use of a packer. And the packer is can be visible here. It is UPX. Basically, a packer is something like you load a binary into the memory and then it is decompressed in the memory. So we can reduce the size of the binary by compressing it and then decompressing it in the memory. And here we can see that the UPX is being used. So the first thing that we need to do is that we need to decompress it from the UPX just to be able to even work with it on Ghidra. So I will use a simple Debian Docker here. So maybe I will mount my current directory in maybe /dir. And okay. And now I'm just going to install the UPX, the tool. So install UPX. Okay. And when I try to run it, then you can see that it is the ultimate packer for executables. And it has a command -d, so we can decompress a file that was packed with UPX. So let's go to this directory. And we have the challenge without flag here. And I can use UPX -d. Maybe let's compare the size. So it is like 320,000 before, and let's see the size after the decompression, and yeah, more than twice as big, so it really works in this case. Okay, and now I have this file decompressed, which means that I can use it in Ghidra. I mean, we cannot really see that it is decompressed in when we just look in like less. However, we can see that there are some references that can be read right now. So I'm going to run Ghidra. I will do that on my other screen. So I will show it in a short while. Okay, I need to wait a second because it is a really big tool. So okay, it is still thinking, but okay. So here I have Ghidra, and as you can see, Ghidra shows the disassembly, but it can also try to somehow decompile the code. It tries to decompile the code. It is not possible to do this as good as in Java, but basically you can get a pretty neat results. So the first thing that we need to do is that when the application is written in C, then it starts with the function that is called main. So let's have a look at main. And yeah, I think that the compilation is not over. This is why we're not getting all the information. Perhaps after a few seconds or maybe after a minute or two, we'll get it will look a little bit better. But let's see what happens. We can see that the code is we can see that the code is getting some random variable in the beginning. Then we have the printf function, so we can guess that this printf is showing us the challenge. Then we have getLine. So getLine is used to get the response from us. And the return value of getLine is the length of the input. And we can see that the length is being compared to 1/4 hexadecimal, which means that the expected length is 20. But getLine includes the new line character at the very end. So the first information we can get from this very short snippet of code is that our response should have 19 characters. This is the first basic information that we can get from this code. Okay, maybe I will run the Docker again because well, now I have the binary file, so I can just run the challenge. Okay, so what I know right now is that my response, oh sorry, we don't know it yet. I know that my response needs to have 19 characters. So this is the first information that we got. Okay, let's go back to Ghidra. So if the length is 20 in this case, because including the new line, then we can see there's another function that is called check response. Okay, as you can see, the argument for printf is now included, so Ghidra did that in the background. So let's have a look at check response. And here we can see that the basically the param2 is the response. We could get that from the main function. And I can rename a variable here. So when I know that the param2 is response, I can just rename it for response. And now everywhere this param is called response, so it is easier to read the code. And in here we can see that we have some checks, whether the response starts with RESP underscore, and then the last character must be a new line. Okay, so what we know right now is that the format of our response needs to be RESP underscore, and then in general it needs to have 19 characters. So this is the information. So let's have a look what's going on next. We can see that there is the SHA1 hash being calculated of something. And truth being told, we really don't need to go into much details what exactly this code does at this point. We can see that it is not really complicated, so something rather easy is going on in this place. But what is important is that the data that is being hashed is an argument to SHA1 update. So what I can do right now is that I can run a debugger, and I can just check what is the argument to this function. And this is all I need to know. I don't need to go into much details what exactly happens here. So this is the, let's say, simple approach that we can have. And, oh, sorry, I will just go back. And in the disassembly, I know the exact memory address in which the SHA1 update function is being called. Okay, so let me go back to my shell, and I think I need to install GDB. So let me do this. Okay, let's install it. And then I run the binary, and I will set a breakpoint on this exact place because I want to know what is the argument to SHA1 update. Basically, SHA1 update has 3 arguments. We can check that in the documentation. The first argument is the special object that is being used to create the hash. The second argument is what we want to be hashed. And the third argument is the length of the second argument, basically. Okay, so the debugger is installed, so now we can run it. And we can set a breakpoint on this address. Okay, so I will copy it to the clipboard. Sorry, without the semicolon. And now I have breakpoint at this point. So let me run the application. And I know that the response needs to have a specific format. So I'm going to use it. And I am making sure that it has 19 characters. Okay, and at this point, the breakpoint is fired. So I can show the disassembly of what's going on at this place I am currently at. Let's see if this is correct. Okay, and the call convention in the 64 bits CPUs, or maybe we can check that what is the call convention, because basically different arguments are in different registers of the CPU. So we need to know in which register is the second argument to a function. So maybe let's Google that, because, well, this is something that is really easily Googleable. So x64 call convention. Okay, maybe Stack Overflow would be the good place to have a look. This is the 32 bits, but we need to know the 64. Okay, and now we have the sequence. So basically the first argument is in the register RDI, the second argument is in RSI, then RDX, and so on. So because we are interested in the RSI, because we are interested in the second argument, because we want to know what exactly is being hashed in here, this is exactly what we are going to do. So we can use the print RSI, if I remember correctly, And we can only see a number, and this is because this is a pointer to a memory. And we know that this pointer must point to some kind of a string of maybe some characters. So we can just use casting to characters, and let's see what we got. We got something that looks like a challenge. Maybe let's confirm that. Yeah, this is exactly the challenge. Starts with 35 and ends with BB3. And then there is appended another string that is called magic salt. So this is exactly what's being hashed in here. So we know that this application appends the magic salt. Of course, we could get the same information from here by just looking at the code, similar to the Android example, but it would be a little bit more difficult in this case. I mean, actually this magic string is in this number. So this is not really that obvious in this case. Okay, and then what happens here is that after the hash is computed, then we are getting a substring of this hash. Basically, we are getting the, let me think, there's 5, there's 0x13, so we are getting the 19 minus 5, this is 14 characters from the hash. So the response is not the full SHA1 hash, but this is a substring from this. The string is being written to a local variable, and then we get a fragment of this local variable. This is basically what happens in here. So we know that this magic salt is being appended, so maybe one more time, let's use Python to implement exactly the same. So maybe I will define a function that I will call response, and it will accept a parameter called challenge. So what I need to do in the first place is that I need to append the magic salt. It was, yes, magic salt. And then my response is actually, maybe I will just use another variable that is called hash, and I will get the hash of the string, and I will return the string resp underscore. I'm not sure if the hex digit returns string or byte string. We will see if I get an error or not. And then I need a substring of this hash. So basically I need the, if I counted it correctly, 14 characters from the hash. So maybe let's try it. So I have this challenge, and then I will try to, well, it didn't copy. Let's try it again. I will try to read a response. Okay, this is what I thought. So I need to use byte here. This is the charm of Python 3. Okay, and I have the response, so let's have a look if it works. Okay, it works. Of course, because I'm running it locally, I'm not getting the real flag, but as you can see, I'm getting the response that here would be flag. So in a short while, I will just try to connect to the service and show you that it works. So basically, we could use Ghidra, maybe the name of this tool is here, Ghidra, to see the disassembly, to decompile the code and try to get the idea what is going on. So basically the only thing that is going on is the SH1 hash is being computed, but before the magic salt is being appended to the challenge. Yeah, IDA can get a little, well, basically every single decompiler will get a little bit different results. I wouldn't say which one is, the best. Basically, it is worth trying to decompile code in different decompilers because, well, they might just get different results. Okay, so I have my code to compute the response. Maybe I will install netcat in this Debian to not leave it at this point, and I need to connect to this, I need to do it quite quickly. I need to copy this challenge. I'm not sure if I do it quick enough. Then get the response. Okay, I think I was too slow. So I need to prepare a little bit better. I mean, I could write a code that would create a socket and set it automatically, but in this case, it is not really needed. So, okay, I have the response, and here's the flag. A little bit of reversing. So at the very end, I figured it out that this flag is really similar to one of the other flags, which was a little bit of brute forcing. So yeah, that was the idea. The challenge was about the challenge was all about the reverse engineering and understanding what exactly this this code does. Okay, the flag. Sorry, it just disappeared because. Let's have a look again. Okay, so now we can see that the challenge response is solved. Okay, I was replicating the logic in C, compared it, open terminals to copy paste the response. Yeah, basically Python is really useful for this type of stuff. But another approach for this challenge would also be to use the more dynamic analysis. So you could also use Frida, the tool that I mentioned before, to this, and with Frida you could also dump the arguments to SHA1 update. So this could also be done, but I guess that you need to look at the disassembly in the first place to get any idea of what is going on. At least from the disassembly you can clearly get the idea that the response needs to start with the resp and the underscore. Yeah, the first challenge in this challenge was actually to unpack the executable, because without doing so you wouldn't get anything that made any sense. This is the basic idea of packers. There are some packers that are not that easy to unpack. I mean, with UPX we have tool to do UPX minus D and we get the result, but it is not always possible. Okay, I think that this challenge response was solved only by one person, so congratulations, good job. And the next challenge, crypto, is solved by 2 teams. And well, in this one, we have an information that we are experimenting with a new encryption technology that is called encrypted crazy brain. And this is our proof of concept, and our goal is to log in as administrator, but we have credentials for another user. There is a little hint in this description of this challenge, and the hint is encrypted crazy brain, and if you get the first letters, then you have ECB, and I will tell you what is ECB in the cryptography, but if you know something about the cryptography, then you might recognize the acronym ECB, and this was a little bit of hint in this challenge. So let's have a look what's going on. Maybe I will close all the other tabs, and I can use the user Paula with the password wedding. Okay, I am logged in, but I am not an administrator, so I cannot see anything. And let's have a look at burp, because there are a few interesting things to notice in the login request. First of all, that this login request has some kind of token. We don't know what kind of token it is, but basically we can see it's here. And second of all, when I'm trying to log in a few times, I'm getting exactly the same cookie. Okay, so when I'm sending the same parameters, I'm getting the same cookie. But when I change the token, then the cookie is a little bit different. Not the whole of the cookie, but a part of this cookie. And basically, because the hint in this challenge is that it has something to do with cryptography. And in cryptography, we are usually working on blocks of 16 bytes. Okay, so what I can do right now is that I will change the size of this window response so that it has 16 bytes in one line, so we can easily see what exactly is going on with this session. And then have a look when I'm changing one character in this token. Then you can clearly see that only the second line is different, which means that only the second block is different. But let's have some background, because in this challenge, the session is encrypted in the ECB mode. So I will show you what it means and what are the consequences. So I will import a Python module to do a cryptography in the AES algorithm. And let me create an object with some random key, not that random. Okay, and I also need to add mode, and I will add the mode ECB. So in a nutshell, the AES algorithm can work only with bytes that are with blocks that are 16 bytes long. Okay, this is the definition of the algorithm. It can only encrypt or decrypt 16 bytes. But in the real world, well, we need data which is not 16 bytes. And this is where we need the cipher modes of operations. And one of the simplest mode of operation in cryptography is called ECB. That is electronic code book. Okay, and it is really simple. We just need to split the plain text into blocks in which each block has 16 bytes. Okay, but this raises a little problem. That is, what if we want to encrypt data that are not 16 bytes long, or maybe it's not a multiplier, or the length is not a multiplier of 16. And we will see an error that data must be aligned to block boundary. So basically, the length of the data must be a multiplier of 16. And to do so, we need to use padding. Okay, it is not in crypto-util. I don't remember the name of the module. Let me have a look. PyCryptodome pad. Crypto-util. Okay, crypto-util padding. Okay, and the idea of padding is that we can add something at the very end of a string so that it has the 16 bytes. And as you can see, here's the idea. We add the same characters at the very end, and then we have another function that is called npad that removes the padding. Okay, so now what I need to do, in order to encrypt any data in AES, I need to add the padding. And now the AES can work with the data with padding. And it is, what is also really important is that if I have a data that is 16 bytes long, like this, 16, then the padding is also being added, and it is just another block which is just with the padding. Okay? And this is the basic idea, the basic information that we need to have in order to solve this challenge. So let's have a look that when we modify the length of this token, we can see that the length of the session cookie is also different. Okay, so when the token is longer, the cookie is also longer. But what we can also see, and this is a direct effect of using ECB, well, I think that the length is incorrect of the line. Let me try to do this again. Okay, so we can see that that a few of these blocks are the same, and this is because in the ECB mode each block is encrypted separately. This means that when we try to encrypt the same block twice, the ciphertext is exactly the same. So we can see that there are several exactly the same ciphertexts. So we know that the only thing that can be encrypted in here is the uppercase A 16 times. That is really important. That will be useful with what we are going to do in a short while. Okay, maybe let's try something else. I will copy the session cookie and okay, I will go to the main page and I will add the cookie header. And a really good way to test cryptography when we assume that something is encrypted, for instance, I will try to do this trick with the same length again, but something is not right here. B8 BBB is the first one. Okay, now the length is okay. And the good way to test some stuff with cryptography is just to randomly change it. Like just change 1 byte and see what happens. So maybe I will try to change 1 byte at the first block. And well, in this case, nothing happened. That's interesting. Maybe let me try to change the last block. And now I'm getting some kind of cryptographic error. Okay. Maybe let's try to change the second to last. And now I have an error that the encrypted data is incorrect. So basically I can see what is encrypted at the very beginning. So now I know that the content of this cookie is actually token is equal to and the value of the token. But I don't know what is at the very end, because when I changed the 1 byte in this second to last block, then basically it was decrypted into some sort of gibberish. So another trick that I can do is that it might work or might not. We will see. It depends on the length. But I will try to copy the second to last block one more time and then change the last instance. And then I'm getting another error that the user doesn't exist. So the username was encrypted badly in this case. Okay, the basic idea of what I am trying to do right now is that I will try a few different ciphertexts because I just want to find out what is being encrypted in this particular block. I mean the block that is second to last, because I know that it starts with token is equal to and the token, but I don't know what is at the very end. So I'm trying to find it out. Okay, so maybe I will try the trick with repeating the block one more time. Maybe it will work, maybe it won't. Okay, maybe I am a little bit unlucky. Okay, I tried to do it a few times, and basically with the first test of cryptography are just randomly trying things. But we can see that, maybe I will show that in the render. We actually get some information. The information is a little bit intersected, but we can see that there is something like the ampersand username and then the token. This is because I pasted the token again. And then we can see that here's the me is equal to Paula. So after doing some tests like this, I can get a pretty good guess that the information that is being encrypted is token is equal to the token and username is equal to, well, Paula in this case. Okay, so maybe I will open a text editor and I will fiddle with it a little bit. So let's have a look. I have 16 bytes in here, and my guess, I'm doing it this way because I want to have a few blocks. I want to see where exactly is the block boundary. So this is the 0th block, the first block, the second block, and so on. Okay, so I can guess that originally the thing that is encrypted is token is equal to something, and then username is equal to Paula. And then we have the, maybe I will write just a capital P, but this means that there is the padding. Okay, so this is what will be encrypted when I use this type of token. I will show you that this is the case. So yeah, as you can see, I have 2 blocks, and I know that the first block is the token is equal to AAAAA, and the second block is username is equal to Paula. So what I want to get at the very end, so my goal is basically to get like token is equal to, well, anything, but I want to have username is equal to administrator. This is basically my goal, and I can do that using an attack that is sometimes known as ECB block shifting. So I will move the blocks of ECB a little bit, and thanks to that I will be able to encrypt the cookie that I like, because I have control over the token. So I can encrypt any text I like. Okay, so let's have a look. Let's say that the value of token will be AAAAAA maybe, and then username is equal to administrator. So in this block, I will have encrypted the data username is equal to, well, adminis in this block, and then traitor in this block. Okay, and using this trick a few times, I will be able to encrypt anything I like. Okay, so now I need to think about the exact form of this cookie. So the problem with, or maybe there's not really a problem. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes of padding. And the general idea is that if I have 10 bytes of padding, then I need to have 10 bytes with the value 10. So what I want to do right now is that I want to encrypt within the token AAAAA and then username so that it is at the beginning of the block. So let's have a look. Maybe I will copy it from here. So I have username is equal to administrator. And then if I counted it correctly, I need to have 10 bytes of padding. So I can use like 10 bytes of value 0A. This is the hexadecimal form of 10. I am not sure if it's 10 bytes. I need to do it again. 1, 2, 3, 4, 5. And then here. Okay, so what I have right now is that the first block is token is equal to AAAAA. The second block is equal to username is equal to adminis. And the third block is traitor with padding. So this is exactly what I want to have. Okay, so I can paste it right here. Maybe I will add some breaks so that we can see where a block ends. Okay. So the original value is token is equal to something, and then we have ampersand username is equal to something. So I just need to make sure that the ampersand will be in the first block. So I want to have token is equal like AAAAA and then ampersand username something. And this is really easy to do because all I have to do is to remove one of the A. Okay, so now I know that the first block is token is equal to AAAAA ampersand. So basically this block is equal to a token is equal to AAA ampersand. This block has the information token is equal to AAA. This block has the username is equal to adminis, and this block has traitor and padding. So now I can create my own cookie from all these blocks. And so basically this will be the first block, this will be the second block, and this will be the third block. And if I did everything right, I should be logged in as administrator. So let's have a look. So the first block, the second block, and the third block, and I'm getting an error, so I did something wrong. Let me think. Okay, I know what might be going on. The application actually uses the URL encoding, so probably when I use the %0a, then the generated token also has %0a. So this is actually something that I don't like. Okay, so I need to do it a little bit differently. I want the last block to be with padding only. Okay, that's the idea. And I can control that because if the token is long enough, okay, it needs to have exactly this length, then the last block will be fully with padding. Oh, sorry, and username. So 1A more. So I will use this this token. And now I can be pretty sure that this last block in here is a block with just a padding. I can easily confirm that is that when I delete a single A, then I have one block less. So I'm hitting the block boundary. Okay, so this is what I need to have. So basically, this is just padding. This is what I need to have. And now I need to prepare the cookie in such a way that the administrator is at the end of the block. So I will just try to do it maybe like here. So okay, here we have username. Okay, so I need to encrypt a block with me is equal to administrator, and the block that is before needs to have the user na at the very end. That's the idea. Okay, let me think if it works. Or maybe a little bit differently, sorry, because I think that this equal to would also be encoded. So I think I need to have username is equal to here, and then administrator and the automatically added padding. And that should be fine, I think. Let me think about this. Is it going to work or not? I'm sorry, I think that it is because of the hour right here in Poland, a little bit late, and my thinking is not that straight at this point. Let me think. Maybe I will have a look at a little bit cheat sheet. Basically, all the challenges has a health check, and those health checks are trying to solve this challenge. So I prepared a health check for this challenge, and basically it will be a good cheat sheet for me to make sure that everything works right, because let me have a look. Okay, maybe I will just show you the code of the health check, because it shows the idea. Okay, so there is my goal. So my goal is to have token is equal to something, just as I show at the very end. Then username is equal to administrator, and then I can have another fake parameter at the very end. It will be ignored by the application. So I need to encrypt token that contains this amount of the letter X. Okay, and that's the first one. Then I know that the first block would be token is equal to access. The second block is access and username is equal to. Okay, so that's the first step. So now I have the first two blocks that I need to use. Then I need to encrypt the block in such a way that the administrator will be at the very beginning of the block. So I need this amount of the letter X. And then I need to use the administrator. And now I know that the second block is basically this, the administrator and US. Okay, and okay, I pasted it here. And the last block needed to be just padding, so I had it already in here, just padding. So let me try it. Okay, and afterwards I am logged in as administrator. Yeah, I guess I am not sure if my explanation of this one was really good. But the idea in general is that because the ECB mode is being used in here, and I have a control over the token which is encrypted in the cookie, I can encrypt any data I like. So I encrypted first a token with letter X and specific length. Then I encrypted another token that started with access and finished with administrator. So I encrypted this block. And then I needed to have a block with just padding. And because I'm using the ECB mode, the blocks are not interconnected in any way, which means that I can just use it as, you know, Lego or something like this. So I have a few encrypted blocks and I'm creating a completely new ciphertext from those blocks. This is a really interesting attack, and we had a few applications in the real world that actually had this type of mistake. So yeah, the suggestion here is to never ever use ECB. If you ever used encryption with the ECB mode, then well, this is bad. Okay, and we have 3 challenges left. Maybe I will start with the easiest one of the 3, and this is basically by a little mistake, but because the challenge was supposed to be a little bit harder. But the second challenge is significantly easier, in my opinion, than the other hard ones. Okay, so let's have a look. Okay, sorry, I need to run the browser in the very beginning. We have a site with some golden thoughts, and we can, if we like any quote that shows up in here, then we can save it as our favorite. Okay, and let's have a look at the communication, at the HTTP communication. And we can see that we have a cookie here that looks like a hex string. And when we decode the hex string, then we can recognize that the cookie is actually a serialized object in PHP. Okay, and there is a well-known class of web application vulnerabilities that is called, well, deserialization vulnerabilities, that makes it possible to execute any code when the application is using the deserialization function. In PHP, the function is called unserialize. We also have a little bit of a hint that the frameworks that are being used in this application is Laravel and also Mockery. So what's going on right now is that certain libraries have a chain of classes that can be abused in order to execute arbitrary code. And originally the challenge was supposed to be about finding your own chain of classes, but basically it turned out that you can use a well-known tool because one of the chain from the tool works here. And the tool is called the question is if it's possible to solve if we don't know the format of the cookie. My guess is that perhaps if you try to copy in Google at the beginning, then you would guess the information that, well, this is the unserialized format from PHP. I think that maybe you would get that information. Basically, you need to recognize what the cookie is all about, because okay, I'm getting something from PHP. Yeah, but nothing about unserialized. Yeah, basically I think that the starting point for this one is that you need to recognize the format of this cookie, that it is a serialized PHP object. And in the very beginning, you need to recognize that it is a hex string. I guess that this is easy to recognize, but if you have never seen the serialization format of PHP, then yeah, indeed this can be difficult. If you also tried to run some kinds of automatic scanners on this one, then they could tell you that, well, this cookie looks like a serialized object, and maybe you want to have a closer look at it. So there is a tool that is called PHP GGC, and this tool can be abused, or not abused, just used, to generate payloads that exploit the unserialized function. And here we have some so-called gadget chains, so basically a chains of classes that can be abused to execute arbitrary code. And as you can see, there are several chains for the Laravel framework. And we know from the source code that Laravel is used in here. And it basically required some sort of exploration, but you could find that the Laravel RCE6 is the payload that works. Okay, so I will show you how to do it. So I will go to the PHP GGC. So what I need to do right now is that I need to use the name of this payload, and afterwards I need to use the PHP code that I want to execute. So basically I want to execute an operating system command, and our goal in this challenge was to read the /flag. Okay, and as you can see, this is the object that is being generated. It looks really similar to the one in the cookie. Oh, sorry, the question was about EBC. If it's possible to solve if we don't know the format of the cookie. Well, the first step that I have shown you was about fiddling with the blocks, or maybe changing it randomly, and then you would get some information about not being able to decrypt something. And this was basically a way to figure it out, what exactly is inside the cookie. That was the idea. This is why the application shows this quite specific information, that this data is invalid, and we know what exactly was being encrypted. Maybe I could have made it a little bit easier, but it was actually directly inspired by a bug that we found in our penetration test in the past. Basically, the application was showing information what was encrypted, and then we figured it out what exactly was the format of the cookie, and well, we were able to exploit it. So this is why I did it this way, because I had this direct inspiration. Maybe it was a little bit too difficult after all. By the way, all the challenges are going to be up for the end of the next week. So if you want to have like another shot at these challenges after this video, then you can still have 1 week. After the 1 week, we will like take them down. But until that, you can still have fun with those challenges and try to fiddle with them. Okay, going back to the PHP GGC, it generated a payload that makes it possible to execute arbitrary PHP code. You can see the code in here. The problem is that the serialized object in PHP can have null bytes, and the clipboard doesn't work well with null bytes, so I'm going to encode the payload into the URL encoding, and you can see some null bytes in here, like %00. And what I'm going to do right now is that I'm going to decode this payload from URL and then encode it as ASCII hex. And after, oh sorry, this is the wrong challenge. This is the golden thoughts, so the PHP challenge. And after pasting it, the PHP code got executed on the server. And yeah, this vulnerability is also known as object injection gadget. So the idea is to recognize that this is a serialized object of PHP in the cookie, and you could use the well-known gadget for Laravel in order to exploit that. So here we go. Okay, the next hard challenge was Python calculator. This challenge is also inspired by a bug found during a pen test. So we had an application in which you could execute your own Python code. And the goal of the creators of the application was that the Python code should be quite limited so that you cannot execute arbitrary operating system commands. So I can use the calculating. I can do some mathematical expressions and it works, and this code executes. But for instance, if I try to import the OS module in Python, then I'm getting the information that I'm not allowed to import OS. The question is this one would be pretty hard if we do not know a tool like PHP GGC, right? And the answer is yes. It is possible to find the gadget by yourself, but it is quite difficult in this case. Okay, so going back to this calculator, as you can see, we are not allowed to import OS. And you might Google for something like Python sandbox escape, and what is funny, the first suggestion is Python sandbox escape CTF. And quite often the escapes involve referencing special properties of objects in Python that starts with an underscore. But the sandbox I'm using here, basically this allows that. Whenever a variable starts with an underscore or method starts with an underscore, it is disallowed. So in this case, it is not possible. Maybe I will use burp in here so that we can see the request on the left and the response on the right. It should be more legible. Okay, so the first thing that we might notice is that if we try to import a module, then it says that we are not allowed to import this particular module. But it doesn't say that we are not allowed to import anything at all. So the first thing that we can do in this case is that we can iterate over all modules in the Python standard library and check if any of these modules will be able to load. So let's do it. And I can Google Python module list. Okay. And I will use some JavaScript tricks to get names of all the modules. So basically, when we have a look at the HTML, we can see that the name of the module has class xref. Okay, so I can use a function that is called $$ in the console of the browser and find all elements with class xref. Okay. And then, for instance, when I'm getting the text content of all of these, as you can see, I have names of all the modules. But I need to generate a little bit of Python here. So this is what I'm going to do. So basically at this point I have a module. And the code I need to have is that I need to use try. So I'm trying to load this module, and if it is successful, then I will use a show function, because in the original code, you can see that the show function is basically an equivalent of print. Maybe I will show that here. So when I say show something, then I'm getting this in the response. So I will try to import a module, and if it succeeds, then the name of the module will be printed. But if it doesn't succeed, so any exception happens, in other programming languages you would use catch here, but in Python we have except, then, oh sorry, and it disappeared. So once again, so I am trying to import a module and show the name of the module if it works. If it doesn't work, then I'm just ignoring it. Okay. Now I can join everything with a new line, and there is a really useful function in the developer tools of browsers that is called copy, and it just copies it to the clipboard. So now I have a big snippet of Python code when I try to import every possible module from the standard library. Okay, and the code will not work because of a few modules, and I will just remove them, because names of some modules starts with an underscore. So this doesn't work. So I know I will not be able to load them, and the built-ins is a reserved name, so I cannot use it in the code. Okay, and afterwards, as you can see, I'm getting names of two modules, fractions and math. So maybe let me go to the Python console and see what we can do with those modules. Basically, the module that will be interesting is fractions. Let's have a look at the members of fractions. And as you can see, one of the members of fraction is a module that is called sys. And this is basically the same what I would get by saying import sys. Okay, and this is really interesting because when I am trying to do import sys, it doesn't work. I am not allowed to do so. But when I'm trying to import fractions, and then maybe sys is equal to fraction sys, then as you can see, I managed to find a way to get a reference to this module. Pretty neat trick. By the way, I have no idea why you can access sys module from fractions, but that's the way it is. Okay, so now let's see what interesting stuff we have in sys. Basically, sys has an attribute that is called modules, and here we have references for all other modules installed, loaded. Whoa, I'm sorry. My dog just barked. Okay, so here we have references for all modules that are loaded in these applications. So for instance, sys modules OS is a reference to the module OS. So I cannot import OS, but I can do so. Wait for a second. Okay, sorry, we needed to calm the dog down a little bit. But he doesn't really want to. I guess that he just wants out. Anyway, going back. So as you can see, I can get a reference to the OS module from sys modules. So that would be pretty neat. But when we try to access sys modules in the sandbox, you can see that sys modules is specifically disallowed here. This is one of the solutions, but, well, this one was blocked. So let's find another way to get a reference to the OS module, or maybe any module than from sys modules. I mean, why do we want to get access to OS? Because from OS we have a function that is called system. And this function makes it possible to just execute arbitrary command. So this is basically the reason why we want to get access to OS. But there are also other modules in Python that makes it possible to do so, like subprocess. And in the end, we will get access to subprocess because OS is going to be blocked, to spoil a little bit. Okay, but we know that we can access sys, and sys works. So maybe let's have a look at the documentation of sys. And we will just find out what type of values, I mean what types of objects this module makes possible to access. And there are many things that may look interesting, but what we need to get is, let me find this. I don't remember it from the top of my head, so I'm looking for this as well. Okay, I think that we are close. Okay, there is a property that is called metapath. And basically with metapath, you can load other modules. So let's have a look at this. So we have sys and then metapath. And as you can see, we have importers in here. So basically classes that make it possible to import other modules. And if we have a look at the last one, then it has a property that is called find module, if I remember correctly. Okay, and from this we can just find any module we want to. So for instance, subprocess. Okay, and afterwards we can use another method that is called load module. We can get that from the documentation, but I'm not going to show you every piece of the documentation. Just this is something that maybe even using the tab completion in the IPython, you can get the information that we have the load module here. Okay, so this is a way to get a reference to subprocess. So this is what we are going to do. So let's check if it works. But there is another problem, and this is actually, I don't know, a little bug in the sandbox that I'm using, that I cannot use the subscripts. So I cannot use the subpath and the brackets with 2 in here, because it just doesn't work. As you can see, I'm getting an error. Fortunately, in Python, when we have a list, we can use the pop method, and we can pop basically any element we like. So I can add an argument to pop with the index. Okay, so I'm going to use the pop method here, and I'm going to pop this element with index 2. So maybe finder is equal to this one, and then find module. And maybe I will try to load module that is called subprocess. And at the very end, I'll try to show the subprocess. And as you can see, I got a reference to the subprocess module. Okay, sorry, the subprocess is already here. So now when I have it, maybe let me go back here. When I have access to subprocess, then in subprocess I have a method that is called just run, and I can run arbitrary command, for instance id. Okay, maybe I will show you just one more thing, that I can read the response from this command. I need to use the capture output parameter in here. So I can run ID and then capture output is equal to true. And well, IPython crashed. That's interesting. Maybe let me try again. Import subprocess and then subprocess run ID capture output is equal to true. Okay, and then as you can see from the std out, I can get the response. So let me do this here. So I'm going to run the command, maybe ID, and maybe I will just show the response. And something is wrong here. Okay, the equal to sign. Okay, so this is a proof that I was able to run the ID command in here. And our goal in this challenge, as in the description, was to execute flag py. So yeah, afterwards we are getting the flag. This is a really interesting example because it shows you that even if you allow users to execute arbitrary Python code or maybe in other languages, and you think that you blocked a lot of stuff, because of the dynamic nature of Python, it might be possible to get access to the same stuff on some other way. So basically I wasn't able to access subprocess directly because it was blocked to import subprocess, but then it turned out that I was able to import fractions. From fractions I could get the access from sys, and from sys I get the subprocess. Basically from sys I can get anything thanks to the find module. So this is really neat, and there are many more tricks like this in Python that, well, maybe in the future in some other CTF this is something we can also use. Okay, and now the last challenge, which is the most difficult of all challenges in this CTF. I will try to perhaps in this case I am not going to dive that deeply and this is because it would take a really long time. So I will show you some general ideas that you need to use in this challenge, and if you are missing some details, then perhaps after this video you can read a little bit about the vulnerability in question that is in this challenge, because it is a really interesting vulnerability that is getting much traction recently. And maybe let's have a look at the challenge. It is really simple. So all we can do is to get some information about the air pollution index in various cities around the world. Like for instance in Warsaw there's the pollution index, and well, basically that's the whole functionality of this application. And this one wouldn't be possible without the source code, so I provided the source code. And the type of vulnerability that we need to look for is hinted in the title. This is air pollution. And in the JavaScript world, there is a very specific vulnerability that is called prototype pollution. So basically in this one, we will have to exploit this vulnerability. So as I said, I will show you the solution in a little bit simplified form, because with deep diving it would be extremely long to talk about this. But let's start with some basics about prototypes in JavaScript. Basically, in JavaScript, we can create an object without defining its structure. So in Java, we need to have a class, and then we can create an instance of this class. In JavaScript, we can just create an object without defining, well, anything about this object. However, this object has some methods by default, like for instance, the maybe value of, right? And I didn't define the method value of in this object, but it still has it. So this is because this object has a prototype. And basically, if a JavaScript engine cannot find a property in an object, it looks for that property in the prototype. And we can get access for the, let's say, the global prototype from object prototype. Basically, the prototype of this object is equal to the object prototype. So for every object, the last proto is going to be object prototype. Okay, and well, maybe let's see some example about the prototypes. So I will create an object 1, and it will have a property called x, and then object 2, whose prototype is object 1. Okay, and as you can see, the object 2 doesn't have any properties, but when I try to access x, I'm getting x from the object 1. And this is because the JavaScript engine cannot find the x property on object 2, so it looks for its prototype. The prototype is object 1, the prototype has this property, so it is returned. When I try to get access to toString, for instance, then object 2 doesn't have this property. Its prototype, the object 1, also doesn't have this property, but the main prototype of all objects has toString. So this is why every single object in JavaScript has toString. This is the basic idea of inheritance in JavaScript. So this means that because every single object has the object prototype as its main prototype, it means that if I can add a new property on the object prototype, then every single object has it, right? Like the X object didn't have the ABC property in the beginning, but because I added a new property to the prototype, now every single object have the property that is called ABC, because every object is basically inheriting from object prototype. So it can have some interesting side effects if we are able to pollute the prototype, because this is what is called prototype pollution, that we are able to add new properties to the prototype. And so what can be the effect? Imagine that you have this piece of code that if user admin, this is basically something that we do in the code, so we are not checking if this is true, but we are just checking if this property exists, basically. So if user is admin, then do something, right? And if we can pollute the prototype and add a new property that is called isAdmin, then basically every single user is admin, because for every single user it is going to be true. This is why prototype pollution can have, well, pretty damaging side effects. Okay, and okay, so this is the first. Basically, we need these two steps. The first step is that we need to find a way to pollute a prototype in an application, and then we need to find a way how to exploit that. So maybe I will open the source code. On the second screen, I'm running the Visual Studio Code because, well, then it will be much more legible for you. Okay. Well, regarding the open positions, thank you. I'm quite happy where I am right now. So, but if you want some trainings or maybe penetration tests or maybe other CTFs, then we are open to further cooperation. Okay, we can see the JavaScript code of this application. And at first, it might seem that this application has some kind of protection about prototype pollution, because we can see that the proto is here, the constructor is here, the prototype is here. So it is called unsafe key, so it seems like it blocks using these keys. But we will see that we could bypass that in a second. Okay, and the typical place in which the prototype pollution can happen is the merge operation. And the general idea is that if we are merging two objects, and one object has a property that is called proto, right? And then we will copy all properties from this object to another object. And then when we copy proto, we will actually overwrite the original prototype. Right, so this is why the merge operation is usually the way to pollute the prototype. And basically, to access the prototype of the main object, we can use the __ proto, but we can also use constructor prototype, because the constructor for any object is a function object. So this is basically the same as object. And as we already know, the object has the prototype property, so the constructor prototype also, the constructor also has the property prototype. So this is basically equivalent to xproto. Some inner JavaScript stuff. And okay, so as we can see, we have merge in here, and maybe I will run this application locally in the beginning so that we can see what exactly is going on in here. So in the beginning, I will have to install all the dependencies. So creating a huge node modules. Okay, let's wait for a short while. Or maybe a little longer while. Okay, and now I can just run the code locally so I can test what exactly is going on. So I'm doing it so that I can add a console log in here with the object prototype, so we can see what exactly is going on with the prototype of the main object. So maybe I will go to the browser, and I will refer to the local version of this challenge. And it doesn't load. Okay. So maybe I will just change the place to which burp sends the request. Okay. So the idea is that I can use prototype pollution using the merge operation. And if you have a look at the internet about how to exploit prototype pollution, you will see that it is generally about sending object like this. So you add a proto property and you are trying to pollute the prototype. In this case, there is a protection that if a key of the object is proto, constructor, or prototype, then it is ignored. However, after this check, you can see that there is a trim operation. So any white space at the beginning or the ending of the object will be deleted. So what we can do right now is that, for instance, we can use constructor with a space, and then maybe prototype with maybe 2 spaces, and add a new value like x. It is equal to ASD. And then it doesn't work. Let's have a look what I'm doing wrong. Constructor. Okay, maybe without the city I will start with the constructor. Okay, and now as you can see in the console log, and the console log was logging the object prototype, there is a new property in the global object prototype. So I can well, add new properties to the global prototype so I can change behavior of the objects. And in this application, there is a JavaScript library used that is called Hogan.js. And this is a JavaScript templating library. And I think that maybe this one I will show in a really simplified form. Maybe I will just write some write-up later on, but maybe let's have a look at the code. Okay, so we can see that the application is trying to render a template using the Hogan library. And if it fails, it then creates a string with this template. And function is in JavaScript basically an equivalent of eval. Okay, so it's basically evaling the function. And it looks pretty neat because it looks like in this case, we need to find a way to make this line throw an exception, and then we want this template to be a string. And it is really possible. Oh, it doesn't work in this case. A string. Okay, maybe Visual Studio Code doesn't want to search in node modules. Quite surprising. Maybe I will use another command that is called ripgrep. Okay, let me just have a look. Okay, basically, when you are using Hogan, you can get that from the source code of the Hogan. You can add an option that is called as string, because by default, Hogan returns the template as a function, but we can make Hogan return the template as a string. So this is something that we need to use in this case, so that the template can be used just as in the string, basically. And to do so, we will have to do a little bit of magic. So basically, we need to access the constructor prototype, and then we will make the string will be always possible. But we need to do it in 2 steps, and this is because of some inner workings of Hogan. So I need to add an array in here, and I need to add some random property to this array. And when I do so, as you can see, the application well, basically hangs. This is because some kind of error happened in the background. So as you can see, I polluted the prototype, and because of that, the application doesn't work properly at this point. So let me try this again. And what I can do also is that there is basically a bug in the Hogan. I guess I will do a little bit of write-up and I will send it to you, because at this point I didn't really intend this stream to be this long, and I am a little bit tired, to be honest, at this point. So I'm going to write a write-up because it is really interesting. So basically the idea is that I can pollute the prototype, and I will add more and more spaces with basically any value. So for instance, I will name the value test, or maybe test123. Okay, and it also needs to be an array. And then this value needs to have a special argument that is called name. And the name can be anything I like. And at this very point, I can inject my own JavaScript code. So I will inject a code. I can also get it from the source code, what kind of code I need to use in here. So basically I will require my own JavaScript module. Maybe I will finish at this, and the code should work, but it doesn't. Let's have a look. add the Visual Studio Code. Okay, maybe I will just try do it a little bit simpler. What's going on here? I guess that this might be the reason. The number of spaces in every single one instance needs to be different. Okay, so I run it again. And it still doesn't work. Okay, maybe I will try. Maybe I will try to just copy the payload and let's see if it works. So I have a short Python code that generates the payload. Okay, and it looks like this. Okay, this command failed in this case because I'm running it locally, but basically the idea is that I was able to pollute the prototype, and I changed the way the JavaScript library that is called Hogan worked. And basically when it created a string and I forced it to create a string with the S string here, then when it was creating a string, it just iterated over all properties in the prototype and added it in the code. So then when I had another property which contained the snippet of JavaScript code, it made it possible to execute my own code. So basically after all of this, when I go back to the remote version, maybe I will open it here. Okay. Then, as you can see in the response, I am getting the flag. So, yeah, I'm aware that this explanation was really short and not really going into details, but yeah, I must admit that I didn't intend this stream to take this long. So I think that I will write a write-up and I will share it with you so that you can understand better what exactly is going on in this challenge. So this is how we could solve all the challenges. I hope that you learned a lot when you are trying to solve these challenges by yourself, and also when looking at this video. If you enjoyed the CTF, then well, we are open to organize similar events in the future, so please let us know that you liked it. And if you have any questions, then ask them on chat right now. I will wait like 1 minute for if any questions pops up. And well, if you don't have any questions, then I can just wish you a good weekend. And I hope that this knowledge about some stuff that you get from the CTF will be useful in your further work. So, thank you very much for your attention, and especially for these 7 people or 8 people who managed to be here until the very end. And yeah, thank you. That's all from my side. I will just wait a little bit in the chat if there are any questions, but if you don't have any questions, then that's all. So, thank you. I'm turning off the video, but I will be on the chat for a while, so if you have any questions, then you can ask. Thank you and have a nice weekend.